Here's an interesting problem. We've got a situation now where we're taking the limit as x approaches 1 of 1 over natural log x minus 1 over x minus 1. The problem with this guy is that when you put 1 in for x, you get 0. That's 1 over 0. So then we have to go, well, what happens when we're getting really close to 0? And so as we get close to 1. And what happens is as we get close to 1, we get a decimal really, really close to 0. So we're dividing 1 in the first case by some decimal really, really close to 0. What this means is that the limit for that first part goes to infinity. Same rule for the second. If I put 1 in, I get 0 again. I can't do that. But if I put a number that's really close to 1 in there, I have a really small decimal and that small decimal on the bottom, again, makes us approach infinity. So I have an indeterminate form, infinity minus infinity, and we can't do this. So here's what we're going to do. We're going to use L'Hopital's rule. The problem is, right now, L'Hopital won't work because we've got these constants in the numerator. What we're going to do is we're going to combine the fractions by multiplying the top and bottom on this fraction by the natural log of x, and the top and bottom on this fraction by x minus 1. This is no different than things that you've done in the past when you've had to solve for x's. Okay, we're just putting these fractions together. But what happens is we get the limit now as x approaches 1 of x minus 1 minus the natural log of x. That's on the top. And on the bottom I have the natural log of x times x minus 1. Okay? This is a lot easier for us to work with now because now I've got a function on the top and a function on the bottom, the derivative of which shouldn't all be 0 because we've got some natural logs running around. So what we're going to do is we're going to look at these guys then, and we're going to let f of x equal x minus natural log of x minus 1. So the derivative of that is 1 minus 1 over x and then 0. Okay? So I can put him back into the numerator here, and then let's look at the next one. The next one is g of x equals x minus 1 times the natural log of x. Well, we've got a product rule, this guy. So g prime of x is equal to the derivative of the first, which is 1, times the natural log of x, plus the derivative of the natural log of x, which is 1 over x, times x minus 1, which looks like this. So it's going to be kind of a messy looking, complicated sort of fraction-y thing. So here we go. We're looking at the limit as x approaches 1 of my new numerator, 1 minus 1 over x, over my new denominator, natural log of x plus x minus 1 over x. And again, if I put 1 in for all of these things, I'm going to wind up with another indeterminate form. I'm going to end up with 1 minus 1 on the top, which is 0. And on the bottom, I'm going to end up with 0 plus 0 divided by 1, which is 0. That's indeterminate again. Well, what does that mean? That means that I now take the derivative again of f of x. Well, the derivative of 1 is just plain old 0. And remember, negative 1 over x, that's the same thing as x to the negative 1 power. So when I take the derivative of just this part right here, when I take the derivative of that guy, that's negative x to the negative 1. Bring your exponent down, multiply, so negative 1 times negative 1 is positive 1, and then subtract 1. So this is going to be x to the negative 2. That's actually not so bad. Okay? The g of x guy is a little bit more work. So this is f prime again. G prime of x, so g double prime. The derivative of the natural log is 1 over x. And then I've got x minus 1 over x. So I can use the quotient rule, or I can rewrite x to the negative 1 and use product rule. I'm just going to go with low d high minus high, let's see, low d, I didn't even write that right, low low d high, which is 1, minus high d low, which is 1, over low low. So it looks like this. And now I have a new numerator, new denominator. So once again, stepping into my limit. So the limit as x approaches 1 of x to the negative 2 over 1 over x plus x minus x plus 1 over x squared. It's kind of squeezed down there, but here we go. Now when I substitute a 1 in, I'm looking at 1 over 1 squared over 1 over 1 plus, and then x minus, let's see, that should be x minus x plus 1. So I've got a little whoops here. This is getting complicated. X minus x plus 1. So those x's cancel, and I wind up with 1 over 1. So this is going to go all the way down to 1 over 2. Now, it looks really complicated, but the calculus part isn't what's so bad. It's the algebra. The derivative part isn't what's so bad. It's the algebra. You really got to pay attention to your algebra here because there's a lot of places to go wrong. But this is a problem where we can combine a fraction initially so that we can get an indeterminate form to start taking derivatives.